All right, guys, welcome to Learning Target 7.4a. We're going to start using some proportional theorems here. So if you look at this one, this is called the side splitter theorem of a triangle. And it basically says if you have a line parallel to one side of a triangle and it intersects the other two sides, kind of like in our picture here, then this side and this side are proportional to these two sides. Okay. And then we'll kind of look at the converse of it being true, which means if these two sides are proportional, then these lines are parallel. So let's just look at some examples to make this basically make sense. But basically, you're going to be doing what you have been doing. So if you take a look here, if we want to solve for x here, and we got a little different look here because it says x plus 1. Basically, we can set this up two different ways. We can take and look, but the left side is basically proportional to the right side. So we can take x plus 1 to 12. And if I started with x plus 1, so I'm going this way, then 3 is proportional to 9. Okay. So then to solve that, we're going to cross multiply like we always do, have been doing, okay? So if I cross multiply, we have to be a little bit more careful here because when I cross multiply this way, it's not just x anymore, it's x plus 1. So that means I have 9 times x plus 1 equals 12 times 3. Okay. Now we have to distribute, and we get 9x plus 9 equals 36. I'm going to subtract 9. We get 9x equals 36 minus 9 is 27. Divide by 9. We get x equals 3. Which would make this side 3 plus 1, which would make it 4. Okay. Now, the other way, you could go the opposite way here. I'm not going to do this, but you could have also flipped this and put 12 on top and gone the other way. But you can also go across and set these up, and it'll work by going across this way. So you could have done x plus 1 over 9 equals, and then start with 12. Oh, whoops, not x plus 1 over 9. Oops. Sorry, x plus 1 over 3 and 12 over 9. And notice you would get the same thing, okay? Or we can go the opposite way, 3 and flip them upside down. So you would get the same thing. All right. Are these lines parallel? So we want to know, are these two lines, are RS, so basically is RS parallel to XY? So to determine this, we need a proportion. So we need to set up a proportion. Okay, so basically we know that for these to be parallel, that we can take 8 to 12, and does that equal 12 to 18? And to know that, we can just multiply, okay? If we take 12 times 12, does that equal 8 times 18? And so when we multiply 12 times 12, we get 144. If we take 8 times 18, we also get 144. So if those are equal, they're proportional. So we know we can say RS is parallel to XY. So yes, RS is parallel to XY. So I'm going to draw in the little arrows there. Okay. All right, let's just keep going here, solving for X. Now, this is kind of an add-on to that theorem, but basically if we have multiple parallel lines, then the in-between segments are also proportional. So we can just set up a proportion. So I always like to start with x. So I'm going to go x to 12. equals, if I started with x, then I gotta start with the bottom, 4 to 8. So if I cross multiply, I get 8x equals 12 times 4 is 48. Divide by 8, x equals 6. Just as a reminder, you could have set it up and went x over 4 and 12 over 8 would be another option to set up that way. Okay, and let's go to our last one here. Okay, can also work this way. So like here, these two are proportional. So we got 10 over 4x equals 5 over 4. So we're going to cross multiply. We get 20x equals 40. Divide by 20. We get x equals 2. And that is kind of how we use the side splitter theorem. So you can look at practice 7.4a on Delta Math to practice this a little bit.